Hello good day viewers, welcome back once again. Today we're going to evaluate x to the power of 12. Given that x is positive and the x is one of the roots of the given quadratic equation, x squared minus x minus 1 equals 0. Now the first thing we're going to do here is to solve for the roots of this equation so that we are going to know the root which is positive. So from the given equation, we have x squared minus x minus 1 equals 0. Now we're going to make use of the general quadratic formula. So here a is equal to the coefficient of x squared, which is 1. B is equal to the coefficient of x, which is the second term here, which is negative 1. And c, which is the constant, is equal to negative 1, right? Therefore, we have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now, imputing this, we have negative b will be 1, right? Then plus or minus square root of b squared will be negative 1 squared, which is 1. Then minus 4ac, 4ac is negative 4. Then 1 minus negative 4 will give us 1 plus 4, which is 5. Then we have here over 2. So here we have x is equal to 1 plus root 5 over 2. This is greater than 0, right? So this is the root which is greater than 0. Then I check the other root. We have here x is also equal to negative 1 minus root 5 all over 2. This is less than 0. Therefore, we don't necessarily need this root according to the question, right? Now, from the given equation, we have x squared minus x minus 1, this is equal to 0, right? Now, negative x minus 1, let's take it to the other side. So here we have x squared is equal to, the signs will change, so we have x plus 1, right? Okay. Now, from here, let's square both sides of this equation. We have x squared squared. This will be equal to x plus 1 squared. Then from here, make use of this property, a to the power of b raised to the power of c. This is equal to a raised to the power of b times c. So here we have x to the power of 4. This is equal to, the expansion of this binomial here. That will give us x squared plus 2x plus 1. Then this is equal to, remember, x squared is equal to x plus 1, right? So we have here x plus 1, then plus 2x plus 1. Then simplifying further, we get x plus 2x will give us 3x, then plus 1 plus 1, that will give us 2, right? Okay, so now we have x to the power of 4 equals 3x plus 2. Let's put it down here. So we have x to the power of 4. This is equal to 3x plus 2. Now let's go ahead and multiply both sides by x to the power of 2. Then here by x to the power of 2. So that from the left hand side, let us recall again, a to the power of m multiplied by a to the power of n. Since we have the same base, this is same as a to the power of m plus n, right? So here this will be x to the power of 2 plus 4, which is 6. Then this will be equal to, so open this bracket, we get 3x squared. Is that 3x squared? Okay, now x squared is already given as x plus 1. So let us make use of x plus 1 instead of x squared, right? So we have here 3x plus 2, then multiply by x squared. X squared is x plus 1. So here we have x plus 1. Now expanding this, we get 3x squared plus 5x plus 2. So from here we have x to the power of 6. This is equal to 3 into brackets. Remember, x squared is equal to x plus 1. So here we have x plus 1. Then plus 5x plus 2. Now opening this bracket, we get 3x plus 3 plus 5x plus 2. Then simplifying, we get 8x plus 5. Okay. So from here we have x to the power of 6 equals 8x plus 5. Now let's square both sides of this equation. I think from there we will arrive at the 12th power of x, which we are asked to evaluate, right? So now from the left, we have 2 times 6 is 12, so we get here x to the power of 12. This is equal to, now if you expand this binomial, we have 64x squared plus 80x, then plus that is 25. Then remember that x squared value in terms of x is x plus 1, so we have 64 into bracket x plus 1, then plus 80x plus 25. Okay, so from here we get x to the power of 12. This is equal to, now 64x plus 80x from here, that will give us 144x, right? Okay, so we have 144x, then plus 64 times 1 here is 64, then plus 25, that will give us 89. Okay, now this is the value for x to the power of 12 in terms of x. Then let us recall the value, the positive value of x, which we found earlier, right? And what's that? So the positive value of x is 1 plus root 5 over 2, which is also known as the golden ratio. Therefore, we're going to substitute right now. So from where we stop, we have here 144 into bracket 1 plus root of 5 over 2, then plus 89. So from here, 144 divided by these 2 here, that will give us 72, right? So let's finish up here. So that will give us x to the power of 12 equals 72, then into bracket 1 plus root of 5, then plus 89. So from here, 72 times 1 will give us 72, then plus, from here, 72 times root 5 will give us 72 root of 5, then plus 89. So from here, we have x to the power of 12 equals 72 plus 89, that will give us 161. But let us first write this second term here first. So we have 72 root of 5, then plus 72 plus 89, that will give us 161. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye bye.